Action. Alright, so this is kind of what it looks like. And on the back side, it looks the same. So this is what's happening as the angle is increasing, 0 degrees, 90 degrees, 180 degrees, 270, 360. This is what's happening to the value of the function. It's going up to 1 as a max, down to -1 as a minimum. And it just keeps going back and forth, back and forth. Alright, so on the opposite side, it kind of does the same little game. So my advice when you guys are graphing this is just to split it into fourths. So notice I put my 2 pi on the fourth marker. So every step over is like another thing. So it started in the middle, went to the top, went to the middle, went to the bottom, went to the middle, went to the top. So I just dotted them, and then I kind of play connect the dots. Anyway, this is what the graph of y equals sine of x looks like. Amazing. Would it be messy if I put cosine on top? What if I put it in red? Then it will get really pretty. Cosine. Let's do cosine. So cosine of 0 is actually worth 1. So cosine starts at the top. Cosine of 90 is worth 0. Cosine of 180 is worth -1. And it kind of follows the same pattern though. So every step I went from down 1, up 1, up 1, down 1, down 1. Looks like that. So it follows the same pattern. The difference is where it starts at. Oh boy. It starts at the top at 0 instead of at 0. So if I go backwards, top, middle, bottom, middle, top, middle. It's gorgeous. And it goes forever like that. Is that confusing? It would better if I took it away. No. Anyway, so they look very similar. They have a very similar pattern. One way to think of it is the sine function, everything is happening like 90 degrees later in the cosine function. Okay, let's do some crazy stuff. I need to get rid of one of these guys. Let's go back in time. When we were young, it's y equals, what do you think will happen if I do like 2 times sine of x?
Doesn't it get taller and lower?
Yes, it doubles in height, or in amplitude is the magic word. So instead of going up to 1, guess what? 2. Goes up to 2, which is a little bit off my graph. And instead of going down to -1, it goes down to -2. So it just, everything gets, girls, twice as tall, twice as low. And yeah, so that's one thing. Actually, before I start this, I should say something else. So notice from here to here, it's like one iteration of the graph. Before it starts repeating itself, it goes this far. And how far it goes before it starts repeating itself is called the period. Like, you know, like a periodic table or it rains periodic. It just means like time kind of thing. The period on this graph is 2 pi. So a normal y equals sine of x, because it starts repeating itself every 360 degrees. So for this graph, it starts repeating itself every 2 pi. Okay, the other thing that this graph has is what they call an amplitude. Amplitude is kind of like the height, but not really. So the amplitude for this graph is how far it's going up and down from the middle. 1. So on a basic sine function, actually it's the same for the cosine. On a basic sine and cosine function, the period is always going to be 2 pi. How long before it starts repeating itself? From here to here, from 0 to -2 pi, that's also 2 pi in length. From -pi to pi, that's 2 pi in length. That's how long before it starts repeating itself. From here to here, that's 2 pi, another way to think about it. Half a pi, 1 pi, 3 1/2, 3 halves pi, 2 pi. Anyways. So the amplitude is not really the height, it's more like half of the height. Because it's going up 1 and down 1 from the middle. So really the height is more like 2, but the amplitude is just 1. So you can find it by counting from the middle to the top, or you could find it by doing the height and dividing it by 2. Okay, what would happen if I double the height of my sine function? Would the period change? No, it would not. It would look kind of like this. The period does not change. It's still, from here to here, it starts repeating itself. Period does not change. Did the amplitude change?
Yeah.
Yeah. What did the amplitude change to? 2. So this number in front right here is basically the amplitude. It tells you how high and how low it goes from the middle of the graph. Alright, what do you think would happen? Let's get that, okay, we'll just keep that. What do you think would happen to the function if I did that?
Move it up 1.
The graph moves up 1, that is correct. So, actually I don't want this guy anymore, get out of here. So the graph would just move up 1, everybody goes up 1. Did that change the period? No. Did it change the amplitude?
That was only up half though.
Oh yeah, I forgot it's counting by halves. Yeah, if it doesn't, if you move it, but basically if it moves up or down or whatever, that does not change the period, it's still repeating over this space. It doesn't change the amplitude because you're still going up 1 and down 1 from the middle. Okay, even though the middle has moved up. Technically it should be right there, but that doesn't change. It changes the graph, but it doesn't change. Okay, but what happens if I do this? Huh? Left 1, that is correct. We've seen that before. When you put it directly on the x, it affects the x motion, but it does the opposite of what you might guess. It actually moves left 1. Now, okay, left 1, that'd be kind of hard to do on this graph. This is about 3.14, so left 1 would be about right here. Kind of a mess. Pi, this is not.
Well, I get why. I just want to know, like, you woke up and said, let's do this.
Well, some things are best modeled by periodic repetition. Like, I don't know, sound waves, ocean tides, you know, they come in, they go out, that kind of thing. So anyway, these are used to model like real life situations, and then they predict what's going to happen or what you need to do, that kind of thing. Okay. Okay, the only thing I didn't do, and this is kind of new for us, if you put a 2 not in front, like right there, but directly in front of the x, this is the tricky part. What happens is everything happens twice as fast. So they call it a horizontal compression, like an accordion. It doesn't get taller, it just gets squishier. So instead of getting to the top right there, it gets to the top right there. Instead of getting in the middle right there, it's in the middle right there. Okay, everything happens twice as fast. So it looks like that. Get it? So where this point was here, now it's there. Where this point was here, now it's there. Actually, too squishy. 1, 2, 3. Yeah, it should have been right. Yeah, too late. That's a little too squishy. This point out here, 1, 2, 3, 4, 5. Oh, that was pretty close, actually. Anyway, all the points go half as far away from the origin here. Everything gets squished in. So the period where it was 2 pi is only going to be half as big. So now the period is pi. Yeah, I didn't do very good. Let me clean that up a little bit. There. Too many. So now the period, it starts repeating itself. It's back to the middle right here and going up. So now the period's at pi. So to find the period, normal period is 2 pi, but if there's a number in front of the x, you basically do the period divided by that number. And that's your new period, which in this case would just be pi. If there was a 1/2 in front of the x, you would do 2 pi divided by 1/2, which is actually 4 pi, would be the new period. So if you multiply by 1/2, everything happens half as fast, and it slows down. It gets wide, broad, slow. I don't know if I want to draw it with all that mess going on, but no, I don't. Maybe I can draw it this way. That one would move out here, this one would move out here, that one would be way out there. So anyway, it just takes a lot longer to go up and down. Lots of chatting. It's all clear as mud. Perfect. Just bow. Number 1, page 460.
Is it all going to be on graph paper?
No, only 11 through 16 is graphs.
And 1.
Oh, and 1 and 2, yeah. Graph each function. So, do you have any, let's see. Go over here. I kind of already did 1 and 2, but yeah, I'll do it again. So a normal sine function goes up 1 and down 1. You might, if you want your graph not to be so squished, you might want to label a box other than the first one. You might want to label it 1, like you might want 1 to be, I don't know, on the second or third or fourth high. But if you do that, you need to label it. I'm just going to keep with my pattern that I did last time. I'm going to call the second pi. Now technically I could label this would be pi over 2, like half pi. You don't have to use this counting method, but it's probably the best idea. Pi is worth 3.14. So that doesn't really match very well with normal numbers, but it's helpful for graphing sine and cosine. Alright, so sine, where did I say it started at? 0, 0. Actually, I'm going to go this way too. Nope. Nope. No. Why? Okay. Let's go backward then forwards one period. So it starts at 0, 0 going up. So on the first step, it's going to be at the top at 1. On the second step, it's back down to 0. On the third step, it's at the bottom. And on the fourth step, it's back up to the middle, back up to 0. Okay, so what should it look like on the back side? Well, going up at 0 to get to 1. So it should be going down back here. So it's at the bottom on the first step backwards, back to the middle, to the top, back to the middle. All right, cosine number 2 is cosine. It's gonna look pretty similar. They probably drew a picture around here somewhere. It's gonna be pretty similar except for it starts at the top going down. So it's gonna go top, middle, bottom, middle, top. And I'm sure they drew it somewhere. Yeah, kind of like on the bottom of 457 is a pretty good picture. But it's very similar pattern. Okay, number 3, we do not have to draw this. Oh, whoops, number 1. So what's the domain for this function? Yes, it goes forever. You can go as far back, as far forward as you want to. Domain, remember, means x values. So how far left and right does it go? Goes forever to the left and right, so that's all real numbers. And does it ask for the range? Yes, it does. What is the range of this function?
What is greater than -1 less than 1?
Okay, it goes between, up and down, between -1 and 1. So the way that you write that is that y is, it's greater than or equal to -1 and it's less than or equal to +1. How's that going to, what's going to change on the cosine graph for the domain and range? Nothing is correct answer. The domain and range don't change for cosine. All right. Yeah, I don't think I need that anymore. All right, number 3. State the amplitude. So amplitude is kind of like the height, but not really. It's how far you're going up from the middle or how far you're going down from the middle. So notice on the graph they're not counting by 1s, they're counting by 2s. So how far is that graph going up from the middle? 3. So on number 3, I'm going to put A for amplitude equals 3. Okay, period. How far is it going before it starts repeating itself? They were kind of nice to us and they made I think it's purple. Is that purple? They kind of colored it, one of the periods in a shade of purple, right? Is that just my book? No, this is just my book. Suckers. All right, anyways. How far is it getting before it starts repeating itself? So it starts at 0, 0, going up. So how long does it get before it starts repeating itself? 2 pi is correct. So that's the period. I don't know why they colored it in on my book, not your guys'. Alright, whatever. Number 5. Amplitude. How far up or down is that graph going from the middle? 4. Amplitude is 4. Period. So, okay, a problem with number 5 is it's going down through the middle at 0, 0, and the next time it's going down through the middle is off the graph. So maybe a better method is look at the top of the graphs. There's different places you could look. Oh, yeah, actually that's kind of a mess, isn't it? The top of the graph. Yeah. Okay, actually, it's, don't want to have to draw this. I give up. There's negative pi. It's going right there. This is negative. There's pi. Okay, anyway. From here to here, it starts, I didn't draw it very well. From here, it's going up through the graph. From to here, it's going up through the graph again. So, how far is it from there to there? Yeah, that's, how did you, there's a few ways you can figure it out, but how did you figure it out, Josie?
I saw the middle point, like the halfway point between was like 3. So then, like, I just do the squares to figure out where it would be.
Yeah.
3 times.
So she's saying 2 squares is worth pi in our picture, and it takes six squares to get from there to there. So if 2 squares is worth pi, then it takes 1, 2, 3 pi to get all the way across. Another way we could have done it is if this is 2 pi over here, this is like 1.5 pi. What's between pi and 2 pi? 1.5 pi, you could say. There, over like that. And this is negative 1.5 pi. So how far is it from 1.5 to negative 1.5? 1.5 to here, 1.5 to there, 1.5 plus 1.5 is 3. 3 pi. Or you could do 1.5 pi, this minus negative 1.5 pi. 3 pi. I probably shouldn't have explained it 3 different ways, but which way was the easiest? I don't know. Seven is matching. Okay, on 7, do you remember what I said happened when you put the 2 right on that variable? It's like the last thing I talked about before we started. You put the, yeah, everything happens twice as fast. So it's like an accordion squish. The period gets cut in half. So this is matching. Which of those has a period of just 1 pi? E, yes, E does, but its amplitude is too tall. It goes up to 2. So the only thing that's changed, it's a normal sine graph except for it gets squished horizontally. So E is too tall, so A, yes. So number 7 is just option A.
If the negative is in front, does it change anything? If the negative-
Negatives are vertical, if you put a negative in front of everything, it's a vertical flip. Okay, so on number 8, it should be twice as tall and a vertical flip. The negative flips it vertically. So instead of sine normally goes up at 0, 0, a negative sign should be going down at 0, 0 for number 8. Number 9 is kind of like number 7. Darn, I wish they wouldn't have done that. It's the cosine graph, but it's happening twice as fast, so it's a squishier cosine graph. So it's going to look a lot like A, but a cosine starts up.
Yeah.
So yeah, option D. Okay, so number 10 is a cosine graph. It should be twice as tall as normal, and the period should just be pi instead of 2 pi. So number 10, it should be a cosine graph, so it should be at the top of its arc at 0. It should be twice as tall as normal, so it should go up to 2 and down to -2. And the period should only be pi for number 10. Alright, I'll let you guys, if you guys want to ask questions later, you can do it, but we'll go on to 11. I think we'll do a couple of graphs. We'll work on all this tomorrow. We'll probably keep going on this tomorrow. I might. I think it's F. Are you talking about 8 or 10? 10 is not F. Okay, anyway, 11. We'll come back to it. Or you can ask me later if you don't figure it out. Number 11, state the amplitude and period and then graph. Do you guys remember how I said you could find the amplitude on those? On 11, what would the amplitude be? 4. It's going to just go up 4, down 4. That number in front is always the amplitude. If there's no number in front, the amplitude is 1. Okay, the period. So normally the period is what? 2 pi. Okay, unless there's a number in front of the angle, like on 7, the period is 2 pi. So there is no number in front of the x, so the period is 2 pi. So this is going to be a normal sine function, except for it's going to be 4 times taller than normal. I might want to zoom out for my graph. Oh boy. So it's going to go up 4, let's see. 1, 2, 3, 4. 1, 2, 3, 4. Alright, so it's going to have to go up 4 and down 4. And so this is a sine graph. Where does sine start in the middle at? 0 going up. So the up, though, on this one, because it's 4 times taller than normal, is all the way up at 4. So first step is up at 4. Second step is back to the middle. Third step down at the bottom. Fourth step back to the middle. And backwards, bottom, middle, top, middle. Yikes. Let's do that. You could kind of cheat on like all the sine graphs. You could just put the same graph and then change the x values and the y values. It could look the same every time. Unless you did like +1, -1, that kind of thing. Alright, 13. We'll stop here after this one. Go back to blue. What's the 1/3? Okay, so 13, what's the amplitude on 13? There is no number on the front of the sine, so it's only going to go up 1 and down 1 like normal. So the amplitude's a normal 1. What is the period? Okay, so the period is normally 2 pi, but since they put a number in front of the x, it's going to be 2 pi divided by 1/3. So there's kind of a little you can think of it as a little formula, 2 pi divided by b, where b is the number in front of the angle. That gives you the period. I don't know if it's big enough to be worthy of a formula, but yeah, it's 6 pi. If you divide by 1/3, that's like multiplying by 3 over 1. So it is 6 pi. So when I go to make my graph, I'm just gonna, it needs to go up 1, down 1. So 1, -1. I'm just gonna put my period on the 4th box, because it's easiest to graph these in quarters, like a quarter step. I don't really care that this is the 4th step over. I'm still going to call it 6 pi, which means I could call this 3 pi. And this one -3 pi and -6 pi. Okay, was this,
Can you explain what you just did?
okay, so the last problem, all the problems we've been putting like 2 pi right there. I'm just going to put the period 6 pi right there, because it's easy if you think of these as quarter steps. So I really want to put it on my 4th box. It just helps make the graphic process easier. Was this a sine or cosine graph? 113. Sine. So starting down in the middle again, going up. So follows the same pattern as the last one.